Well, hello there, geometry students. It's Miss Graham, and we are looking at lesson 5 today in our surface area and volume packet. So we are going to be pulling up pages 12 and 13. Today, we are going to start looking at volume. So the past couple of lessons have focused on surface area, which is two-dimensional spaces, and now we're going to go ahead and look at volume, which is going to be three-dimensional, and we are looking at the space inside of each of these shapes. Today, we're specifically going to focus on prisms and cylinders. Let's start looking at just the general definition of volume to start off what we're looking at in this next couple of lessons. So we're really looking at the amount of space that's going to be inside an object. So let's go ahead and write that down. So it is the amount of space inside an object. Now, we can actually measure it in cubic units. So it could be, centimeters cubed, inches cubed. We could even say, units cubed. So let's go ahead and make a note that it can be measured with cubic units. And let's show a couple of examples of what we could write down. So now, just generally starting off talking about volume, again, we're going to focus on prisms and cylinders today. And then we're going to focus on the other two shapes in our next couple of lessons. So for a prism, as we can see, we have pictured below, specifically a triangular prism. What we're going to realize is that the volume for that will be equal to whatever the base is times its height. Now, specifically with our base, that B value, we're looking at the area of our base. So this idea of area that we've looked at before, surface area, is going to be incorporated into our figure. Here, the area of this base is really saying what's the area of our triangle. And what we're going to do is we're going to multiply it by the height that we have right here, our height h. So it's essentially saying we're taking all of these areas and we're kind of stacking them up all together for this height. So that's how we're going to find the volume of our prism. Now moving over to cylinders, it's a similar idea. We're going to take the area of our base and multiply it by whatever the height is. So it's like stacking all of them all together. So this time, when we write our volume, it'll be, again, B times H, where B is going to be the area of our cylinder's base. Now, we kept it generic with prism because the base can change. It's not always triangles. But with cylinders, our base will always be circular. So that's how we can always put pi r squared, because that's the area formula for a circle. So don't also forget we have to add the height into here. So those are some pieces of information that we do need to know. Now we can actually take these ideas that we came up with and we can apply them in the problems below. So I'm still going to keep, the formulas up here so we can reference them. So let's go ahead and look at example 1. There's 2 examples here. Let's first start off reading the directions where it says find the volume of each rectangular prism. So with the prism, again, we're using this volume formula, and we're going to find the area of each base. Again, the base could be the top 2. I just always like pointing to the bottom. So we have to find the area of each rectangular one and then multiply it times whatever the height is. So looking at this, again, let's write down our formula. Volume equals B times H, where remember the area of the base of a rectangle is its side times its side. So really it's going to be 3 times 2. And our height is going to be 8. So when we multiply all those together, we're going to end up getting 48 units. And remember, this is cubed because we're looking at volume. So I'm going to add the u cubed there. Now, I want you to try part B. Pause the video here, see if you can answer it, and then check with me afterwards. All right, let's go ahead and check answers. So our volume should have been 64 units cubed because essentially we're multiplying the area of the base, 4 times 4, times our height of 4 right here. So volume, if we're starting off with this, is actually not too complicated. Fortunately, if we have, our rectangular prism. I will tell you, once we move to our prisms having a different base shape, like a triangle or maybe a hexagon, it is a little bit more complicated. It does step up. So speaking of getting a little more difficult, that's what we're going to do on examples 2 and 3. So we're going to go ahead and look at those. Now, I will tell you, for example 3, there was a piece of information missing that we actually need. So I just wanted to point out and have you add this before we look at the problem, that the side length of our hexagon right here, this S, will be 2 feet. So go ahead and add that in your picture, and then we'll practice that problem in a little bit. So example 2 here, right? We want to find the volume of a triangular prism. Again, we're going to have, B times H, where B is the area of our base. Well, keep in mind that this triangular prism is kind of on its side. So this 15 represents that height. So I could always label it as that. Just keep that in mind. But the tough part is, okay, this triangle, I got to find the area formula for that. Remember, the area formula for a triangle is going to be base times height divided by 2, or 1/2 base times height. Technically, I do not know what this height is. I know what the base is, right? The base is 12, so I technically have 1/2 times 12, but I don't know what my height is. So looking at this, I kind of gave you a little bit of hint from my uncovering here that I labeled this length as 6 because it goes exactly through, it bisects this segment and creates a right triangle where we have our hypotenuse of 10, our leg of 6. Hey, you know what I'm thinking? I'm thinking some good old Pythag, right? Some Pythagorean theorem. So let's plug in 6 as a leg, 10 as a hypotenuse, and do a little bit of math. So I'm going to kind of go a little bit quicker here since this is actually a Pythagorean triple, but we actually will get 8. We'll end up with 8 as our height here. So that's what we can plug in to our formula here. So when we multiply that together, we will end up getting 48. Now remember, that is just looking at what the area of our base is for our volume formula, right? Remember, we have the volume equals B times H. So we have to take that 48 and multiply it by our height of 15, and that is what's going to give us the volume of 720 units cubed. Now, let's take a look at example 3, finding the volume of a hexagonal prism. So you can kind of see I started to set up and highlight our base here, and we're going to go through a couple of reminders of how we could find that area. So keep in mind, we have one of these sides of the hexagon labeled 2. So I gave you the hint that we could draw triangles, and essentially if we find the area of one of these triangles, we could multiply it by however many triangles there are in there. Essentially, remember, our area formula, when we are looking at a hexagon, it's going to be area equals 1/2 A times P. So remember, A is the apothem, right? That essentially means, kind of what's our radius right here. I want to figure out, essentially, it's not a radius because it's not a circle, but our apothem here, that vertical connection that creates that perpendicular intersection from our center to the side. So we have to figure out what A is, and then our perimeter. Remember, our perimeter is just all of these sides added together. So easily we know our perimeter, right? That's going to be 12. We know we're going to have times 1/2, right? But we don't essentially know what our apothem is. That's where we have to look at a good old right triangle, right? So we have to figure out, maybe using special right triangles, how we could do this. So keep in mind, a hexagonal prism means there are 6 sides. So essentially, we are dividing, for this big triangle, we are dividing 360 by 6. So that way, looking at that, we get 30 degrees for that specific area that we're focusing in on. So now, keep in mind, sorry, I think I just said 360 divided by 6. That should be 60 degrees. I'm already starting to look and find an error. Oh my goodness. So 360 divided by 6 Yeah, that should definitely not be 30 degrees. That should be 60 degrees. But then keep in mind, where does the 30 come from? That's dividing by 2. That means multiplying by half. So essentially, we're taking 360, dividing it by 12. All right? 12 of these little triangles. That's where this little degrees gets to be 30. Some of you might have gotten a little lost on that. So let me just draw the triangle to represent what we're doing. Okay? So we have our short leg times root 3, and our short leg times root 2. We came up with that because this angle measure right here is 30 degrees. Together it's 60, so half of it is 30. That's where this idea comes from. Now, keep in mind this whole length is 2, so half of it is 1. That's our short leg. So to find the hypotenuse, we know what that is, but we don't want the hypotenuse. We essentially want that long leg, which is going to be 1 root 3. So that is our apothem, which is what we're going to plug in right here. So I can uncover that. And looking at this, I'm actually going to keep it in radical form so we can go ahead and rewrite it. So it's 6 square root of 3. And again, I can round mid-problem, but that might change my answer in the end. So let's just keep it 6 root 3 right now. And I know all that work was just for the area of our base, just for the area of the hexagonal prism. So now we have to take that and multiply it times 10, that height. So let's fill in what we know. Again, V equals B times H. Fill in 6 times square root of 3 times 10. I misread my handwriting. 10, which is our height. So when we do that, we get 60 square root of 3, or if you put this in the calculator and let's say round to 2 decimal places, what we would get is 103.92 feet cubed. It didn't really tell us if it wanted it in exact form of radical or decimal, so I just put both kind of to test that on out. All right, so look at this. We're cruising, we're doing well, looking at prisms. Do not worry, we will definitely try some cylinders in the future and maybe a combination of them. So let's go ahead and turn to our second page, 13. So we are on page 13. Let's go ahead and look at problem number 4. So you can see we're finding the volume, but it's a composite figure. So really looking at this, what I did was I kind of shaded 2 areas, a lighter green and a darker green, to represent kind of our 2 prisms, specifically rectangular prisms. What I'm actually going to have you do is I want you to complete this problem right here. I'm going to have you pause the video. I want you to try to find the volume of these 2 prisms, and then you can add them together for the total. So go ahead and try it, and then push play when you are ready to check your answer. All right, so here's what my work looked like. I wrote the formula for each, and then I realized to find, the area of our base. For the bottom one, it's going to be 7 times 10, and the height is 4. For our lighter green one, the base is going to be, it's still the same of 10. It's going to be times 2 because that's kind of that angle measure. Sorry, not that side measure given. It's times by 5, which is our height. So we get these 2 areas, and then when we add them together for the total area of our composite figure, we get 380 units cubed. So hopefully that was a little good practice with you, and we did quite a couple of prisms. So now, as you can see, we are looking at example 5, and that's where we're going to find the volume of a cylinder. So maybe we kind of have to think back to that formula for cylinders for volume. Oh, wait a minute. It's the same as a prism, the area of our base times the height. But specifically, it's really nice because we know the area of our base will always be a circle, right? So we know it's going to be pi r squared as that volume. So for me to start off, I'm going to just write down our formula. The volume is base times height, and really reiterating that, our base volume is going to be pi r squared times h. So I can see in this picture here that 4 is my height. I can easily plug that in. My radius is 9, so I'm actually pretty good to go here. So I have pi times 9 squared times 4. Now keep in mind when we see the word exact, that really means we don't want to round our problem. We don't, want to have a decimal that keeps kind of going on and on. We want as exact as possible. So similar to radicals, right? Sometimes we keep volumes in terms of pi in order to make it as exact, because we know pi is some decimal that keeps going on and on and on, and the symbol represents an exact way to do this. So essentially what I'm doing is 9 times 9, which is 81, and then doing 81 times 4. Taking that result, which is 324, and just writing 324 pi. We're saying we're multiplying those two pieces together, and that gives us an exact way to represent the volume. And since we're looking at inches, it's going to be inches cubed. Now, if I said, round to the nearest tenth or hundredth, this is where we could put this in our calculator, right? We're all familiar with the pi symbol or typing in 3.14 to multiply times that. We could do that, but it's always good to practice reading those directions. So let's go ahead and look at number 6. So number 6, well, maybe it kind of builds off of number 5. It says find the height of a cylinder. Wait a minute. So we're still working with cylinders. You can see I kind of drew a nice little picture to visualize this. And it wants us to find the height. So looking at, our equation here, it wants us to solve for h. So in the problem, if you read this, it gives us the volume. It gives us the radius. So this is going to require a little bit of algebra. So think back to your algebra teacher last year. Think about how you had to isolate a variable, because that's what we're going to encounter. So for me, what I'm going to do is I'm going to kind of label my picture that I have here. So maybe I can label my radius as 4. I can say my total volume at the bottom. So I'll go ahead and do that. My radius is 4. My total volume is 216 pi feet cubed. And what I can do, is take that formula of B times H and really substitute in pi r squared times H. Because that's the same formula that we're using. Now, I know what the volume is. Let's put in 216 pi. I know what the radius is. Let's put in 4 for that. And let's keep H as our variable. So this is essentially what we have. Now, for me, I know that at 4 squared is 16, right? I have 16 pi. My ultimate goal is to get h by itself. So for me, I'm actually going to divide both sides by 16 pi. Now keep in mind what happens, right? This cancels out on the right side. But here we can actually do 216 divided by 16. And when we divide pi by pi, they just cancel out. So when I put this in my calculator, I end up getting 13.5. And then we know on the right side, h is isolated. It's already alone. So I know that's my measurement. Now, how do I know it's feet? Well, they gave us feet cubed. And remember, if we're looking for height, that's one-dimensional. So that's why it's just feet. So our final answer is 13.5 feet. Now we're going to go to our last problem, number 7. Now, I will tell you, this is a really fun problem because it incorporates both ideas that we went through today, cylinders as well as prisms. Now, I'm going to have you start off by reading through the problem first. So go ahead and read through the problem. All right, so this problem has a cylindrical glass. It has certain measurements, and this whole thing is filled with water. And then the water in here is poured into a dish, right? A prism per se, right? And we want to see, hey, will this dish hold the amount of water in here, or will it overflow? So we're looking to see, hey, what are the volumes of these two shapes, and how do they compare to each other? So again, writing down kind of our goal before we label each of the shapes. So our goal is to find, I definitely am looking at this, and I want to see if I can find the area of both and see if the prism volume is larger than the cylindrical volume. Interesting. So again, the purpose of pointing out areas, we have to find the area of each base. That's what it's referencing, finding the area of each base and seeing if this prism's volume is big enough, if it's larger than the cylindrical volume. So let's start off by labeling each of our pieces. So our radius is 4 here, and our height is 5. So let's go ahead and label those. And I want you to practice finding the volume of the cylinder. Pause the video and play it when you're ready. All right, you can see we should end up getting a volume of 80 pi, or if you found the decimal, it's around 251.33 inches cubed. So we're going to do the same thing with our cube over here. We're going to label each of the pieces. So I'm going to label this side as 5. It's 5 inches wide. I'm going to label this as my 9. It's 9 inches long. And this will be my 2 inches high. So go ahead, pause the video, see if you can find the volume of this dish. All right, so looking at this, I plugged in my information and I saw that that prism, that dish, was 90 inches cubed. Now, it didn't include pi, so that's why I took our result of pi and found the decimal of it. So looking at this, right, we're taking this amount of water and trying to pour it into this water. Sorry, this dish amount. Will this overflow? Yeah, you can see, yeah, the dish will definitely overflow since this number is bigger than that one. So let's go ahead and write down our response. So yes, the dish will overflow since 251.33 is greater than 90. All right, look at that. We finished the video lesson for lesson 5. So what you can do right now is you can go ahead and submit your notes, and then next time with class we will start off lesson 6. So have a good rest of the day.